What if shining light on a substance could tell you what it's made of? That idea has a name: infrared spectroscopy, a technique that uses light to learn about molecular structure. In this video, you'll learn what infrared spectroscopy is, how it works, and how chemists use it to identify chemical bonds in a molecule. Spectroscopy is the study of how light interacts with matter. Infrared spectroscopy focuses specifically on infrared light, which has lower energy than visible light. When infrared light passes through a sample, some wavelengths are absorbed, while others pass through and reach the detector. This happens because chemical bonds aren't rigid. They behave like tiny springs that can vibrate. One type of vibration is stretching, where the distance between atoms increases and decreases. Stretching can be symmetric, where atoms move together, or asymmetric, where they move unevenly. Bonds can also bend, meaning the angles between atoms change. These bends can happen within the plane of the molecule or outside of it, producing different bending motions. Bending inward of the plane is called scissoring and rocking. Bending outward of the plane is called wagging and twisting. Different types of bonds vibrate at different energies, so each bond absorbs infrared light at specific wavelengths. So far, we've covered what infrared spectroscopy is and how bond vibrations absorb infrared light. Curious how much you're remembering? Your personalized practice test, flashcard set, and study guide are all waiting for you. Just tap the link now and keep watching. Future you will thank you. Now, let's look at how this information appears on a spectrum. Infrared spectra are displayed using wave numbers, measured in inverse centimeters. The most useful part of an IR spectrum ranges from 4,000 to 400 inverse centimeters. If a wavelength doesn't reach the detector, it means the molecule absorbed that energy to vibrate. These absorption peaks act as clues, helping chemists identify functional groups in a molecule. For example, an OH bond absorbs at a different wave number than a CO double bond. However, infrared spectroscopy tells you which types of bonds are present. It doesn't reveal the entire molecular structure. By matching peaks to known absorption ranges, you can narrow down which functional groups are present in your sample. To recap, infrared spectroscopy uses infrared light to make molecular bonds vibrate. Different bonds absorb different wave numbers, creating a spectrum that helps identify functional groups. Now that you've watched the video, let's see how much you remember. Head to the link in the description where you'll find Quizlet content made just for you.